You have learned from our previous lecture that the most important characteristic of a projectile is that the one and only force acting upon it is gravity, regardless whether its movement is upwards or downwards, upwards and rightwards or downwards and leftwards. In this discussion, we will learn how kinematic variables interact during the motion of projectiles launched at an angle. It is said that one of the most crucial components of projectile motion is the launch angle, which significantly influences the height, range, and time of flight the projectile will experience during the course of its motion. We should agree at this point that the larger the launch angle and the height are, the longer the flight time of the projectile will be. To illustrate this, let us look at the situation where a cannonball is fired and projected horizontally from the top of a ledge. We understand that the gravity exerts its influence by causing a vertical acceleration in the cannonball, thus creating the parabolic trajectory. Now, let us compare this with a projectile launch at an angle. Figure B in your slide shows the behavior of velocity of a projectile when launched at an angle. The green arrows indicate the initial velocity of the projectile, where the blue ones designate its two components, the horizontal and the vertical. You may notice that the arrows in x-axis have the same length, signifying a constant horizontal velocity. Now, let us look at the arrows found in y-axis. We will notice from this illustration that the arrows become shorter as it goes upward, signifying a decreasing velocity until it reaches this point C. Observe point C in this illustration and choose the best situation that describes it. That is correct. At point C, velocity becomes 0, and from this point C to the ground, we will measure the final position of the object. Eventually, the projectile will be influenced solely by gravity and will accelerate downward. What do you think happens in the velocity? Correct. The velocity increases as it goes down, as it accelerates downward. In solving problems that concern projectiles launched at certain angles, the initial velocity is represented by the magnitude, initial speed v sub 0, and its angle with the positive axis. With this, we can say that the horizontal and vertical components of the initial velocity are v sub 0x is equal to v sub 0 cosine theta, and v sub 0y is equal to v sub 0 sine theta. To determine the positions of a projectile launched at an angle at time t, we will use this equation, where x is the final position along the horizontal, v sub 0 is the initial speed of the projectile at time t, and theta is the direction of the projectile along the horizontal at time t, and t is the elapsed time. Alternatively, in getting the position of projectile in vertical component, we will use this equation, where y is the final position along the vertical, v sub 0 is the initial speed of the projectile at time t, theta is the direction of the projectile along the vertical at time t, g is your gravitational constant, and t is the elapsed time. We would also want to determine the velocity of the projectile launched at an angle at time t. We can use this equation for horizontal component, where v sub x is the final velocity along the horizontal, v sub 0 is the initial speed of the projectile, and theta is the direction of the projectile along the horizontal. For y component, we will use this equation, where v sub y is the final velocity along the vertical, v sub 0 is the initial speed of the projectile, theta is the direction of the projectile along the vertical, g is the acceleration constant due to gravity, and t is the elapsed time. Next, in computing the projectile's maximum height, which is the point in its trajectory when the velocity along the y-axis is 0, we can use this equation. Here, h is the projectile's maximum height, v sub 0 is the initial speed of the projectile, theta is the direction of the projectile along the vertical, and 9.8 meters per second is the magnitude of the gravitational acceleration. Lastly, in getting the range, which is the projectile's horizontal displacement, we will use this formula where capital letter R is the projectile's maximum height, v sub 0 is the initial speed of the projectile, theta is the direction of the projectile along the vertical, and 9.8 meters per second is the magnitude of the gravitational acceleration. Before I end this video, I know you had information overload already. I will share with you that it is possible for projectiles which are launched with different angles but with equal initial velocity to have equal ranges. Meaning to say, projectiles launched at 15 degrees and 75 degrees, which are complementary angles, will have the same horizontal distance provided that they have equal initial velocities. This is the same with projectiles launched at 60 degrees and 30 degrees. With this consideration, projectiles will reach their maximum range if they are launched 45 degrees from the ground. Also, the object will have zero displacement when it is launched at 90 degrees. At the end of this lesson, there are several examples which you may work on. I suggest that you try to solve them independently and compare with your answer on the provided solution. That is all for this lesson. I am Gilmar Di Castro.